Alright, so let's look at question 7. So this is a very practical focused circuitry type question. So we've got a graph of looking at how the current through a thermistor varies as you change the potential difference across the thermistor. So the first question wants you to design an experiment or design a circuit that will allow you to essentially plot this graph. So first thing, you're going to need a thermistor in your circuit, which looks like one of those. So as we want to be able to measure the potential difference across the thermistor, because we need to know what that is if we're going to look at its relationship with the current. And if we're going to look at the current, we also need an ammeter, and the ammeter needs to be in series with the thermistor, whereas the voltmeter should be in parallel. Now, we need a way of changing the current. That's what this question says. So there are two strategies to this. Very commonly, when you're changing the current, you would use a variable resistor, and then obviously we're going to need a power supply finishing the circuit. You could equally have done a slightly different circuit. That looks like this. So we've still got the voltmeter in parallel, we've still got the ammeter in series, but you could have used a variable power supply. So in terms of labeling the component that would allow you to change the current, in this circuit you would have labelled the variable power supply. In this circuit you would label the variable resistor. So that's that one. So in terms of the mark breakdown, there was one for having a voltmeter in parallel with your thermistor, another one for having an ammeter in series, because those are the two measuring devices, another one for essentially having the other components in the circuit you need, so either these two or just this by itself, and then the final one for labeling the correct component as the one you're going to change. Okay, so using information obtained from the graph, calculate the resistances of the thermistor when the current is 0.1 milliamps and also when the current is 0.6. So remembering, to get the resistance we need the V over the I. So when I is 0.10, V is, so lots of people when they did this question read the wrong value of the graph because they weren't looking at the scale properly. So if we go to 0.1 on the current axis and read across, then read down, you should get a value of about 0.44, 0.45. Either of those two would have been absolutely fine. If we look at that, and then at 0.6, sorry, it's not 0.4, it's 4.4, my mistake. And then at 0.6, the V, if we read from the graph, most people manage to read this one correctly. If we go across from 0.6 and then read down, we get what? It's about 17, isn't it? Yeah, 17 volts. So R1 is going to be 44 kilo ohms, remembering the current was in milliamps, and R2 is going to give us around about 28 kilo ohms when you put the numbers in there and give your answer to two significant figures, which would be appropriate here. And just as a quick side note, this question wasn't out of 3, it was out of 2, for getting those two things correct. Okay, so that's those sections there. And then it says, using the results of B part 1, deduce how the resistance of the thermistor changes as current increases. Now, a lot of people clearly did not read this question and so just wrote, as temperature increases, the resistance decreases. No, not all thermistors are like that. You can't just state things. The key word here is it says deduce how the resistance changes. So, the first thing to think of is that as current increases, temperature increases. That's what happens in a circuit. So that's the first point to make here. So that's just something you have to know, and that's the reason we don't leave currents going around circuits, because it causes them to overheat and causes errors in our results. That's the first statement there. The next part is recognizing what part B1 has told you. So you can see here that increasing the current causes the resistance to decrease. So that's your second statement there. So that's us using B part 1. And then this is the point you can draw a conclusion to make your final deduction. So using those two statements, we can deduce that as temperature increases, the resistance decreases. And so there we have the full 3-mark explanation. So to start with, current increases, temperature increases. Current increases, resistance decreases. Putting those two together, therefore temperature increasing causes resistance to decrease. And that's how we do this question.